Good afternoon guys, welcome back. In this video today we are going to do one very famous numerical of a cargo one. So first we will see what is stowage factor and what is load density, then we will proceed to that very famous numerical which is of steel boxes and oil tins. So without wasting time, let's get started. So stowage factor stands for the volume occupied by the unit mass of cargo which is expressed in meter cubic per tons. Next is load density, which is the maximum amount of weight that can be loaded safely on a unit area. It is expressed in a tons per meter square. So these are the two very basic definitions of a stowage factor and load density. Now on the behalf of these two, we will use their formula like meter cubic per tons and tons per meter square. On the behalf of these two values, stowage factor and load density, we will going to do our next question. That is as follows. A hold of 17 meters by 11 meters by 7 meters is to be filled with steel boxes whose stowage factor is equals to the 1.14 meter cubic per tons and oil tins whose stowage factor is 1.87 meter cubic per tons. So if the load density of the tank top is 4.7 ton meter square, calculate the amount of each to be loaded so that the hold is completely filled and load density is not exited. Okay. So first we will find the volume of hold, that is 17 multiplied by 11 multiplied by 7, which is equals to the 1309 meter cubes. So cargo to be loaded according to the load density will be 17 multiplied by 11 multiplied by 4.7. So whenever we have to find that how much cargo we can load according to the load density, so we have to multiply the load density of that tank top with the area of that hold. So we will get 878.9 tons total we can load 878.9 tons. So let's assume to be loaded. Steel boxes will be X tons and oil tins will be Y tons. So we have considered steel boxes as X and oil tins XY to make our equations. So X plus Y will be 878.9 metric tons. This will going to be the equation 1. Okay. Volume occupied by cargo. So whenever we have to find the volume which is occupied by the cargo, so we have to multiply the weight multiply the stowage factor. So for steel boxes we don't know how much is the weight that we are going to load. So for steel boxes, X will be the weight that we have assumed. So X multiplied by 1.14, so which is equals to the 1.14x. Same for the oil tins, which will be equals to the 1.87y. Now 1.14x plus 1.87y will be 1309. This will be going to be our second equation. So we will equate both the equations. So x plus y will be 878.9 and 1.14x 1.87y is equals to 1309, equation 2. So multiplying the equation 1 with the 1.87 to cancel out the value of y. So in this case the equation will be look like this. So 1.87y will be cancelled out by 1.87y. Finally we have the two values of x and some values after the equals to, that is on the right side. So once you minus 1.14x from the 1.187x, it is equals to the 0.73x, which is equals to the 334.5x. So what we have to do, we have to divide this 334.5 by 0.73. So x is equals to the 334.5 divided by 0.73, which is means x will be 458.21 tons. So which means y will be 42096 tons. We'll put the value of x and y in equation 1. X plus y will be 878, so 458.21 plus 420 plus 69 is equals to 878.9 tons. So we can load 458.21 metric tons of steel boxes and 420.69 metric tons of oil tins in that particular hold. So this is all for today guys. We'll meet in the next video. Till then, Jai Hind, Jai Bharat, Vande Mataram.